Hi everyone, I'm Robert. Welcome back to our Data Management 1 module. In this video, we will be talking about the filter function from the dplyr package. Before we get started, we will need to load in our packages, clear our global environment, and assign our dataset. Once we get these done, we can start to learn the filter function. The filter function allows us to select the rows or observations that we want to keep. So what should we pass into the filter function? First, we need to pass in the name of the dataset. And then we will need to pass in an expression or multiple expressions that specify what rows to keep. Notice that we're not going to select the rows using their row names or row numbers, because usually we will have so many rows and it's impossible for us to select them manually by typing in their names or numbers. This is why we need to pass in the expressions. The filter function will keep all the rows for whom the expression is evaluated as true. In R, we have multiple relational operators that can help us to construct our expressions. Most of these are pretty straightforward. I will direct your attention to 3 of them. The first one is the equals operator. Notice that we need 2 equal signs here. In R, a single equal sign means you're going to assign the value on the right to the variable on the left. If we want to compare 2 values, we will need to use double equals. And also you want to pay attention to the unequal operator. This operator starts with an exclamation mark followed by an equal sign. You also need to pay attention to the final operator here, which is the subset operator. The subset operator tests whether the variable on the left takes a value in the vector on the right or the range on the right. So here, the expression will be evaluated as true if x equals a or b or c. R also provides us with the AND and OR operator. These 2 operators allow us to pass in multiple expressions. The AND operator will be evaluated as true if both expressions on the left and on the right are true. The OR operator, on the contrary, will be evaluated as true as long as one of the expressions is true. Great. Let's now look at some examples. In the first example, we want to filter all the rows whose distance is greater than or equals to 1,000. So here, we will first construct our expressions. We want the distance variable to be greater than or equal to 1,000. And then we'll pass this into the filter function. So we'll first write the data frame name, DAT in this case, and then the expression. When we run this slide, we'll get our F1, and we can extract distance from F1 and use the minimum function. This function will return the minimum value of distance in F1. And we can see here, the minimum distance is greater than 1,000. In the second example, we want to keep all the flights from one of the 3 airlines, JetBlue, Southwest, or Delta. And these 3 flights correspond to the 3 codes here, and we will need to use the subset operator. We want to test whether unique carrier is whether it takes one of these 3 values. If it takes one of the 3 values, the whole expression will be evaluated as true, and the row will be kept. So we will pass this expression into the filter function, and we will get F2, and we can use the unique function to see the distinct value in the unique carrier variable from F2. When we use this, we can see in F2, unique carrier only has 3 distinct values, which correspond to the 3 airlines. So now you may wonder, what if we want to find the overlap between these 2 examples? So we want a flight whose distance is greater than 1,000, and it should be run by one of the 3 airlines. In this case, we will need to use the AND operator to combine the two commands that we write out in the previous examples, because we want both of them to be true. So we will pass this whole expression into the filter function. And when we run this, we will get our F3, and we can check F3 using the minimum function and also the unique function. And we can see the minimum distance is greater than 1,000, and the unique carrier variable only takes one of the three values. Okay. And you might also want an example of OR operator. So in this next example, we want to find out all the flights whose departure time is earlier than 5 a.m. or their arrival time is later than 10 p.m. From the codebook, we can see that 5 a.m. is represented as 500, and 10 p.m. is represented as 2,200 in the dataset. So our expression here will be departure time is smaller than 500, or arrival time is greater than 2,200. When we pass this whole thing into the filter function and run it, we get our new F4, and we can see when we use n-row F4, we can see that in F4 we have much fewer observations than in the original dataset. And also want to show you that the AND and OR operator can be used to combine multiple, that means more than two expressions. So here, in this example, we want to find out or the canceled weekend flights who fly more than 1,000 miles. So here we have three conditions. First, it needs to be an weekend flight. This refers to the day of week variable. It should take a value of either 6 or 7. So our expression will be day of week using the subset operator, whether it takes a value of 6 or 7. And our second expression would be the flights should be canceled. This refers to the canceled variable. This is a binary variable. It equals 1 when the flight is canceled. So our expression will be canceled equals to 1. And lastly, we will have our expression distance is greater than 1,000, which means the flights fly more than 1,000 miles. And we will use the AND operator to combine these three expressions because we want all of them to be true. We get F5 when we run this, and when we test using the unique function and minimum function, we can see that the day of week only takes value of 6 or 7, which means the flight is in the weekend, and canceled is always 1, and the minimum distance is greater than 1,000. Lastly, I want to show you a slightly different example. In this example, we want to keep all the rows for whom the taxiing time is greater than the air time. The taxiing time in the dataset refers to two columns, taxi in and taxi out. We need to sum them up and compare it to air time, which is the time in the air. So our expression would be taxi in plus taxi out is greater than air time. Notice in this case, on the left side of the relational operator, we no longer have a single variable, we have an expression. So this is slightly more complicated, but this is very common. So it's pretty useful if you can get used to it now. When we run this, and we can use the minimum function to check our results. We can extract these three columns from our newly created F6, and we see the minimum value is greater than 0, which means for all the flights in F6, the sum of taxi in and taxi out is greater than air time. Okay, and these are all the examples from the filter function, and I will see you guys next time.